So while she's setting up, is it working? Yeah. So let me do some informal survey. How many of you actually built a chatbot before? One. Okay. How many people actually know about chatbots? No wonder. You all worked in here. So what I thought is, I know this is a workshop. I'm not going to give a long talk, but I thought I may just want to introduce a little bit of why we got into chatbots and what we did, maybe for about 10 minutes. You can always shout no, 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 and then I'll get away and then later show you the code. So we'll actually build, show you, still projection problems. We'll actually show you a small bot that we built just for this occasion. What it does is, it goes to PyDelly conference page. It scrapes the events, or scraped the events, because we have to see whether we did it again, because everything timing has changed, and then let you query these events using a chatbot. That's basically what this code is all about. It's written in Python and Flask. Any of you, all of you know Flask, or any of you don't know Flask? Or okay, you know Python, right? Flask is fairly easy. When you see the code, you will understand. The beauty of Python is that pretty much anything you show the code and people will understand what it is. Okay, if you want to follow along, you may need to install a few things. We'll tell you. So I'm glad that we have a break in between. So you can take a break, you can come back, and if you want, you can install. The way we structured the thought is that I'll do this little dance in the beginning. I'll talk very quickly, and then we'll jump in and show you the bot, and we'll show you some code. And if you want to actually build one or modify the one that we have, during the break you can install the requirements and then do it. That's one method of doing it. Another method of doing it is that we'll talk more, we'll show you more code, and you can have lunch, your snacks and come back, and then whenever you want we can break for lunch. Okay? So it's kind of a democracy. You can decide how it goes. Basically, this is a chatbot talk I normally give in a variety of places. So I just whacked it and put it here. So what are chatbots? You already know. Why chatbots is something very interesting, is that it will come through in slides, but it is, in fact, day before yesterday I saw a message that said websites are broken, chatbots will replace them. So just imagine a future that you go in and you go to a website and all you see is a chatbot that comes up and says, hi, what you are looking for? Of course, I will quickly get out of it right now, but because whenever some chat comes up, I think it's a human being. But if it comes up in a nicer manner and it starts coming up in every website, probably will stay. And from a user point of view, you just go to a website and say, I want these things, and the bot tells you what it is. And it is from the same content that is actually in the website. So you may have an option to see whether you want to go and see the website or not and all that. The second thing is that from a website owner point of view, you get actually the questions that users are asking. Or maybe only when they don't find something, they type it, and then you can go through the failed search logs and figure out what people are looking for that is not there in the search site. So that is something that's going to happen. Next one, please. I'll skip through this. Want to get a conceptual understanding. What is a chatbot? Why do we need chatbots? How does a chatbot work? How can we build one? And current chatbot ecosystem. The most important thing, how can we build one? And that is the only reason I am showing these slides. So we'll cycle through quickly. Chatbot is a conversational agent. It's called a virtual agent. It's called intelligence agent, whatever you want to name it. It is formed because of a convergence of the messaging, popularity of messaging interfaces, and AI, a little bit of AI. The AI, it's kind of tongue-in-cheek. It's not really AI. It's a lot of machine learning. It's not intelligence that is going to replace humans anywhere in the near future. And then a large amount of data that is coming. So these are the three things that converge. So if you think about a Venn diagram, one circle for each one of them, and the intersection of it is chatbots. And that's a very, very conversational user interface. The easiest user interface for anybody is to ask a question in the language that you understand very well. Right now it is English, it could be Hindi, it could be Tamil, Telugu, whatever, and Russian. And that is, do you know how the chatbot started? Was the most popular chatbots were all copied originally from a platform called WeChat that was in China. So Chinese are the innovators in this space. And Facebook and Microsoft and all of them had a lot of these plugins, and they played around with it. They looked at it for a long period of time. And the other reason for chatbots are interesting is because we are quickly moving to mobile, and mobile, very quick text interfaces and very quick voice interfaces are more the norm, and because of that, chatbots are going to take off. Next one, please. So why do we need chatbots? There are several theories. One is that it is the future of interaction, and you will see Satya Nadella saying it in the next slide. Okay, a single chatbot may replace several applications. The idea is that I have a mobile app, a mobile device, and I keep on putting apps, and then I keep on taking off apps. So I asked Sahil a bunch of questions. He said, go and load our app, and you'll get all answers for it, right? But what happens if you had one chatbot that can say connects and disconnects to apps as needed? So that will be a cool idea. So you could be one integrated interface for a variety of applications in the back. Take care of boring repetitive tasks, and we'll talk about that a little bit later. And then the story of WeChat we already told. Okay, so some examples of chatbots, customer service bots. These are the most important category right now. Customer service, people ask the same questions over and over and over again. You give the same answers over and over and over again. And sometimes some guy will yell at you, and sometimes some people will ask something slightly different. So what you can do is you can take this and divide it into two sets. One is the human-driven chats and the machine-driven chats. And whenever the machine-driven chats cannot understand what you are saying, and then it goes to the human one, and the human will answer. And now the interesting part happens. When you take the answer, many of those answers can be taken, and you can use machine learning algorithms and learn from that data, and then put it back into the knowledge base of the chatbot. So the bot is actually getting smarter. So that is the true intelligence that we expect to happen in chatbots. It's not happening right now. They're still very dumb, but I think that will change over the next couple of years. A site bot, which is what we're going to show you, you can put a chatbot in front of any site. All you do is that you can use Scrapey or some Python tool to easily scrape the site. You can take all the information and then present it in a very simple chat kind of interface, and that will be a lot more interaction with the site, and it will be interesting to see how that improves it. My favorite one is a teacher bot, because I am a teacher. I try to teach Python to kids, college kids, and also sometimes school kids, though that is not a very successful experiment. The college kids have lots of questions. They're all taught like C, C++, Java, and all these, slightly older, more difficult to learn languages. The entire, about 19 top colleges in the US have all switched to Python as the first language, and we still are not there. So when we start talking to Python, you're talking to people at different levels, and they have lots of difficulties in getting into Python, even though it's easier in the beginning, because they're not used to this colon, this indentation, this all this integer divided by integer is giving a truncated integer in 2.x and all those kinds of things. So what happens if I don't do all that, and instead I give them a Python tutor bot? They ask questions, you give answers, and we started trying to build one. It's an interesting experiment, we'll talk about it. So the commercial product we have right now is called an interview bot. Faisal, who's sitting here, and then Bhavani, they built it. The idea was very simple. We are a subgroup of a company called Focus Infotech, which is like 20-year-old company that is into technology recruiting. The biggest problem is that when somebody says, we want a Java programmer, you put an ad, some 300 people apply. And 200 of them are not programmers at all. Forget about Java programming. They are accountants, statisticians, whoever is looking for a programming job. Of the other 100 people, they do not know, maybe 10 people know Java. So how do you even look through these resumes and figure out what to happen? So you give this to people. So what we do is we created a bot where we give them an initial test, very simple screening test, very simple programs that people have to write, and then test, and then a product that exists. We have been testing it with a bunch of people and launching it in a bunch of. In fact, we do all the recruitment for our group, products group, using this interview bot. Then there are all these service bots, and Pizza bot is the example that Microsoft and everybody does. And if you read any literature, you will see all of these travel booking, pizza ordering, and all that kind of stuff. And there is a whole bunch of other examples. Next one, please. Okay, I'm going to leave this slide, but there are some core concepts. User talks to you, it is an utterance. From there, you extract the user intent, that's an intent. So he says, I want to travel from Delhi to Mumbai, that's an intent. And then you have these entities, Delhi and Mumbai in this case. Then on the dates, there are parameters which are dates, and all this, you need to extract all this from text for the chatbot to interact, somewhat intelligently. Next one, please. So here is an imaginary one. Still Sandy. Okay. So this is, hello, welcome to Pi Delhi. He said, my name is Sandy, I'm a chatbot. He says, somebody says, hi, Sandy. And so this is an utterance. Then he said, how can I help you? Can you tell me what session is going on now at lecture hall 2? That's kind of a redundant question because you know what is going on right now in lecture hall 2, but could be, some other hall. And then say, so it's a chatbot workshop. And then they say, what event is at 10 a.m. tomorrow? You could think about this conversation. This is all that you need to do. What sessions? Oh, this guy is boring. So let me find out what is the parallel session going on right now. You can just walk out of the room and go to the other session. Okay? So these kinds of interface, this is a very simple interface. Okay? And this is exactly what you're going to demonstrate, right? Okay, next one. So a very simplified block diagram of how it works. You essentially have a chat client. The chat client is something you wrote. It could be a simple messaging app. It could be Facebook Messenger. It could be, right now it can't be WhatsApp because WhatsApp still doesn't support the plugins. They will do it in June or something. They said last year they'll do it. Telegram, Slack, all these guys. Okay. Then there is an AI engine. Again, I'm a little, reluctant to use the term AI engine, but that's what the industry terminology is. Basically, what you do there is what is called NLU, which is natural language understanding, where you understand what the user is trying to say, and then natural language generation, because when you say what parallel session is going on today, right now, you should be able to understand right now is this slot. Parallel means there is another track. There is a lot of this implied understanding that goes into this. From the users, you need to understand all this and go to the knowledge base which contains a list of all the sessions, and then pull out that data from the database, then format a reply that looks like a human replied and give it back. This is basically the challenge of the chatbots, right? And then the bot server app access the knowledge base and interact with the AI engine, and this is typically the architecture. Then there is a more gory, fine-grained architecture, but this is like a broad level. If you remember these pieces, that's good enough. Let's go to the next one, please. So this is the gory interface I was talking about. This is back from one of these Microsoft slides. So you have all these interaction channels, and fortunately there are tools today. I think API.ai from Google, bot framework from Microsoft. They will let you switch these channels. You just build your bot, click one button or check one option, and you can be deploying in others. So you don't have to really worry about which channel am I going to deploy. The style of interface may be slightly different, but right now they promise you that because of the text interface, it's possible to do it. We tried to do it with GUIs before and it was a miserable failure, right? So the human machine UX, text, voice, video, virtual world, mind machine and all, that's a little too much for me, the mind machine part. But virtual world I think will happen because VR is happening, and video will also happen. So there is an listening NLP, which is what we called as the input. Chatting is NLG, natural language generation. The knowledge, and then the machine learning stuff that makes all this magic happen. Business logic, and then all these cloud services. You need open APIs, databases. In the case of travel, you say, hey, what is the weather in Delhi? And then it should be able to come back, look up some weather site, tell you the weather, whether to travel or not, kind of stuff. And then forget about these use cases. They're too small anyway to see. So 7 steps for building a bot. Fairly simple. You decide on an application area. The narrower, the smaller, the more internally focused, the better you are. Don't put an external app and then it will go out and bomb More than 3 interactions, it fails. Nobody is going to use it ever again. So try it with some small thing, and small could be a small group of friends doing it also. Most of the interns, we made them do chatbots, all did some really crazy friend chats. Design the conversations. So essentially you saw that one, right? Sandy, what is the parallel session? What is the session right now? That is a conversation. So you design different conversations. It's just like typing a text, like as if 2 human beings are talking to each other. And then so that you get all the scenarios, and this is like what we do as use cases, or initially you do the scenarios, those kinds of things. And then list all the intents that you're going to support, all the entities that you need to support the intents. Like for example, here the entities could be track, session, speaker, topic, to be very, very short. It could be entities, the intents could be what is the session, when is the lunch break, what are the open spaces, what are the lightning talks, where do we go, where are the bathrooms. These are the ones, right? So actions is that for each one of them, where do you pull the data from and provide the actions and responses. Actions are executed by the machines, responses are generated. So you can create a template for each one of these response and plug in the data into that response and display it back. And then the context that you want to keep, because somebody will come and say, what is the session on let's say Docker, and then say what is a similar session, or what is the next such session. Next such is not easy to understand unless you have a context that the previous question was about Docker. So that is basically the context. So you train your AI engine, you give it lots of instances of these dialogues, and then write code for actions. That is the work you have to do. Create and update the knowledge base wherever you are getting the knowledge from. For example, we can keep on going and scraping the website of PyDelhi every 15 minutes or 20 minutes. Create and update the knowledge base and test scenarios, and incrementally introduce features. And one thing I forgot to mention is that log everything. Especially you are interested in the logging the failures, where the chatbot failed. What questions did we fail to answer? So that you can do an analysis and say, didn't we understand the question? Did we not map it to the list of intents we had? Did they ask outside the syllabus question? All those kinds of things you can try to figure out. And then you can go back and support it. The next one, please. Okay, this is just to scare you. We'll go to the next one. Okay, that's it. So we have a Slack channel on building chatbots. Feel free to join. Not much of activity there, but we'll step it up a little bit. I'll let Bhavani take over and enjoy the rest of the session. And if we forget and we are like passionate and jumping around and not recognizing that there is a break, raise your hand, say, shout break, break, and then we'll break. Okay? All right. Thanks. You need this.
Core concepts was already covered by Dorai, like intents, entities. If you have a better understanding of that, that is pretty much enough to get started with it. So this is my guide to start with it. Before that, we'll have a demo of what we're gonna look through in this process. So I'll quickly go through that. So, okay, this is a site bot, or you can call it an event bot for this particular conference. The data might be a little outdated because we have updated the website. So what we did was we scraped all the event details from the website, put it into the database, and attached a chatbot component to it so that it can answer questions regarding to it. So I'm going to chat with my chatbot. Say hi. So I say, who are you? Okay. So what event is happening at 10 a.m. tomorrow? So it couldn't find any events, but it points me to tomorrow. Yeah, so maybe that's the thing. maybe some events around 11. We'll see. Okay. There is something. Okay, and we'll see what are the events are there. So there is one around. There is some internal glitch with it. So this is what we're going to see today. So we'll go back here. So how do you structurize the whole application of how to build a chatbot? So you have your client application, and there's your AI engine, and there's your bot server, and there's a knowledge base. I'll tell you what are these going to do. So this is your chat application. This can be a website, or it can be a mobile application, or it can be Facebook, Slack, whatever front-end interface. This is just a chat interface where you have a place to type your message and you can see your message. You all use Facebook Messenger, WhatsApp, so I don't have to explain more about it. So then you have the AI engine part. This AI engine basically does natural language understanding. It understands what the user says, comes up with an intent, which is mapped to an action. For example, in this case, what is happening at a particular place, lecture hall 1 or lecture hall 2. It means that somebody is looking for an event. So the action would be look for an event. So it goes and looks in the event database and retrieves the content. So that's AI engine part. And its AI engine part is to get what action it is, but the action is actually performed in the server part. That is your backend functionality. So it is closely connected to your knowledge base so that it can fetch the data to and fro from the knowledge base. So it fetches the data and returns back. In some cases, like if you're using API.ai kind of interfaces, natural language generation is a part of it is coupled with AI engine itself, but in most cases it's not. So you can do your natural language, you have to do your natural language generation in bot server itself and send back the response. And it is in turn turned to its chat client. So I have talked about, so these are the few AI engines that are available, but what I have built is not here. We'll add it later. So there is API.ai from Google, Lewis from Microsoft, Bit.ai from Facebook. There is another called Recast, Chatron, and Chatterbot is an open source one. So there is one more called as Rasa NLU from Go Last Mile. So that's what I'm going to use for this session. So the role of AI engine is to detect these intents. What is the intention of the user while he's uttering some statement? And it's going to extract some entities. These entities are basically the details that is required to perform that particular action. For example, if you're booking for a flight ticket, you need your starting location and departure location and the timing of travel and all that. Only if you have all those details completely, you can proceed with the booking, right? So that's extracting entities. So once you have all the data to perform particular action, you trigger that action to your external API or to your backend. And what if, say, the booking failed, you couldn't find any flights for that particular time, you ask, look for flights the next day or an hour later, something like that, right? So that way you have to preserve the context, what the user had already said. And you have to generate the responses, right? So types of AI engine. There are like two types of AI engine. One is rule-based, another is ML-based. So the main core difference between these two is rule-based works well for smaller samples, and it works very well when the domain is so close, when it's focused on one particular thing, like an even bot for PyDelhi, when it's focused on particular things and trained well in small number of samples, it works very well. And it's mostly command-based. You can do smaller commands like get location kind of. If you have used Slack, you can see like reminder set or all are small commands, right? It works there. So when you have predictable responses, you have your conversation very limited, you can use that rule-based decision AI engines. Rule-based AI engine basically works on decision trees. So ML-based, it's similar to Siri kind of chatbots. It's very open, so you have large number of training sets. If it does not have large samples, it's going to fail terribly. So which of these to use? So I would suggest you to combine both. So when you start off with building a new chatbot, you will not have pretty much more data to train your bot. So you can start with a rule-based engine. As and when your data grow, you can slowly move towards more ML-based bots. So bot server, I have already told it. It receives the action and parameters to perform that action, and actually performs the action and send back the response. So knowledge base consists of all the data. In this case, it's going to be all event data. So how I built one. So I'm going to show you some code. Hope you will be interested in that. Before actually showing the code, so this is an open source AI engine or NLU engine by Go Last Mile. So they are using pre-built natural language understanding libraries like MIT-IE or Spacey. Excuse me. So this is pretty much supports or emulates API.ai, bit.ai. Actually, what was we facing was we were building so many bots with API.ai. We have trying out bit.ai, recast.ai, but to switch from one to other, it was pretty much a headache. So we were searching for any other alternative. We were tried out almost every existing platform, as I showed you. There is nothing that you can port from one to other. So what Rasa does is you can import your data from one of these sites and put it into Rasa so that it can emulate that environment for you. So if it's API.ai, you can extract your data from there, put it into Rasa, it will work the same way. So that's one advantage of Rasa. So they have a very detailed documentation you can go through, and they have pretty much everything in there. So there is, as Dorai stated in his steps, there is a series of steps you have to follow, right? One is you have to decide on the conversation. We have already seen the conversation. So next thing is you have to train your AI engine. That's what I'm going to show now. So training your AI engine looks something like this. So it's a JSON file which consists of intent. So yeah. So it consists of an intent and set of entities. Okay. So your intention is to search for a restaurant, and your entities are cosine location kind of. Okay. So I'm going to show my training data. So here. So your training data. This is not emulation of API.ai or bit.ai. It's very specific to Rasa. So you have these common examples, which mean that it is training for both intents and entities, right? So and then you have all these examples. So when a user asks, "Who are you?" it is for the bot to intro itself, right? And when I say, "Hey, hello, howdy," kind of things, it's for the bot to greet back. So when I go further, when I say, yeah, kind of things, it's called I'm affirmating to something. I'm saying I'm agreeing to something. And if I say goodbye, bye, kind of thing, I'm going to end the conversation. And here is where our actual core data comes from. So I'm asking what is the event happening right now? And I'm requesting for an event. And the entities are now, right? So the start location and end position of the entity, which is given here, and what the value actually is, and what entity is. The value is now, and the entity is time, right? So let's go through another example. So here I mentioned what event is happening at lecture hall at 10 a.m. today. So 10 a.m. is time. Today is the day, today. If you ask it tomorrow, it has to be tomorrow's date. So you have to keep all that in mind while actually building it. And lecture hall will be the place. So this is how you structure your event old data, and you got to train it. You can, yeah.
Is it possible to make it as an X time, like whatever time it chooses, it takes out from the database and gives you the time?
You have to train it with a couple of examples before you can do that. These are just examples. These are not placeholders. That's why you're marking entities there. So when you mark it as an entity, that value can be replaced by anything that will take that value and process it. So you can have a clear view of that here. So that Rasa has another NLU trainer UI, so you can upload your JSON data so that you have a clear view of it. So all my intents are here, all the text goes here. So you can have a clear picture of it. For example, if it's here, the entities are mapped like lecture hall and all that. So this is how you picturize your data. Next, you have to train your model. So to train it, you have to write a config file. So as I already said, Rasa supports you two types of ML backend. One is Spacey, which is built on top of scikit-learn. These two libraries are particularly to do natural language understanding. So one is Spacey, another is MIT-IE. Spacey does not work very well when it's very small data set. For example, hi, hello kind of data, it doesn't work. Only when you train it with a couple of samples, it works pretty well. But if you're using Windows machine, your only option is to go with Spacey because MIT-IE does not work on that. And so this is your configuration file. You have to write a small config.json file, and to train it, you use this command, rasa.train and config and your config file. This comes up with a model for you. So I'll show you that. So here is my config file, config.json. Yeah. So I'm using MIT-IE. So there is a file called total word extractor.data. This you have to point to that file if you're using MIT-IE, and the path where your model should be uploaded. So at the end of the ML training, you'll get a model, right? You have to specify the path where the model has to be, and where my data is. My data is under data and sideboard data.json. So that's where my data is. I'm pointing to my data and number of threads to run while training it. Okay, it takes quite a bit of time to actually train it, like a couple of minutes. So I'm not going to do that now. Once you train it, you will have something like this, a model folder with a timestamp, right? So you have, I have trained it over, as you update your data, you have to train it, and at the end of training, you will get a model. So once you have your model, you have to run that model. So to run that, you run it in it's like hosting it in a server and running it there. So I'm kind of emulating it in my local system. So this is the command to do it. So rasa.nlu server, you point your config file so that it understands what data set you're using, like MIT-IE or Spacey, and your model, so that it can predict on top of your model. So once you run it, it runs in localhost 5000 port. So I'll go to localhost 5000 port. Yeah. So if you pass a parameter q, if you could see that with a statement, it will come up with this JSON. So this is similar to making an API call, right? So I'm going to say penning now. So it takes now as time, and it gives you a confidence score. An intent is detected as event request. What is event happening now? What? Font. So this is what I'm going to do. So this is the whole training and getting the intents and entities part. Now you have to plug it into your application, right? So this is my application. So whenever I type a message here and press enter, I'm going to make a call to my backend, okay, which is here, app.py, yeah. So which is here. I'm going to make a call to my backend, and my backend will in turn call the rasa.nlu where it's hosted in 5000 port, right? So it's going to call that and pass whatever I have typed. So I get it in the text. So whatever I have typed, I've got it in request.form.text. So I directly pass it to the rasa.nlu hosting. So at the end of it, I'll get two things. One is an intent of which action you have to perform and set of entities. So now if the intent is going to be event request, you have to get the events, right? If it's not, you have to get a response with respect to that intent. For example, if it's a greeting, you have to get a set of responses. If I'm saying bye, it has to be certain response. So let's hold on with event request for a minute, and we'll see what this random response is. So I'll go to it. Response by. Okay. As I already said, Rasa.nlu does not handle the NLG part of it, natural language generation part of it, so you have to handle it in your code. So what I did here was, so according to my intents or actions to be performed, I came up with a set of responses. What the bot has to say when a person is greeting it. What a bot has to say when he says goodbye. What a bot has to say when he asks for, like, with respect to this particular event, when he has no idea what day it is or what time he has to. Just he is asking for an event. What is your time preference? The bot has to ask such questions. And what does he ask for the events list, for the full events list? You have seen, right? It gives you the event list completely. So what if it find no events? What if it has to intro itself? So all those NLG part have done it here. And okay, when you come to event request part, this is very critical part of the core part of it, and also the critical part of it because you use things like now, tomorrow, today, same time, and all that, right? You have to map it to a datetime object. I hope everybody knows Python here. Yeah, that makes the process very easy. So you have to map all these statements to some datetime object. So if it's now, it's datetime object now. If it's tomorrow, it's today plus 1 day. If it's today, it's today. Same time, now. Second day, now. So when you get a date time, okay, we'll go back here. So if it's an event request, for me to find an event from PyDelhi, I need 3 things. One is the day, another is the time, another is which place. But I don't care, anybody has to mention all these 3 things. Even if I have one of these parameters, I'll pass it. If they give just time, I'll say these events are happening at these places. And you have this event on this day, and the other, I don't care about it. So I'm going to pass this to getEvent method. So, sorry. Can I get a water bottle? So before doing that, we have used this extract.py to extract all these details from the website, right? And it appends it to a database at the end. So that's how we got all the data. So you can see those data here. It's an event description, a date timestamp, and the place where it's happening. So we have the complete database of it. So when you find this event request, when somebody is requesting for event, it is for you to go and look up, just do a lookup in the database and get the format, get the event details. But the pain point I have already mentioned, this mapping. When they say now, you have to map that date time to a datetime object so that you can pass it, you can get it from the database. So when you go to get event, I don't care whether these people mention all of it. If they're not going to mention any of this, I'm going to just send them all the event details with a link, right? So if it does not have day or time, I'm going to just return the event link. if they have a date time, I'm going to pass it to a datetime object. For example, when you look through here, so the event value I get, time value I get from here is now, right? So I can't infer anything from now, so I have to convert into a datetime object. That's when I call get datetime. So given a day and a time, it will return me datetime object. So with that datetime object, I'm actually filtering it from the database here. And if I say 10 a.m., it will look for events until 10:30 a.m. So that's my, for the next half an hour. And it gives me all the events. So if there is no events found, I'll say no events found. So if it can't process it, get event is 2. If it says, okay. So if it can't find any event, it's going to say no events found. If it can't find any inferable amount of details, it's going to send all the details, right? So once you receive that response text, you're going to return the response to your front end, right? And in case something happens, for example, your model can't find any intent. You say something which is not trained for. I'm going to just return, sorry, I cannot understand that. Please train me, or I'm not trained to do that. So you have to always have that system. When something fails, your bot should not freeze. It should always answer something. So that's why it's the whole code and one exception handler, right? So that's pretty much it. If you have any doubts. Either you completely understand it or you never understand it.
I think what we do is, we have it on GitHub, right?
Yeah, GitLab.
GitLab.
It's a public
So
repo.
we'll give you the link, take a break, get some sandwiches, you can come back, you can download the code if you want, you can follow along, or we found all these bugs, you can fix some of them, or we can work through them, right? So I think it's better to be interactive. We just showed you how the whole thing works, so you can download it and start doing it. So let's take, how long is the break? 10 minutes break? Why don't we take
Depends on you.
Yeah, 10 minutes is fine. 10 minutes is fine. After that, you can come back and they'll tell you all the dependencies.
Oh yeah, okay, that's first thing. You have to install Spacey Wheel and scikit-learn in Windows machines alone. That you have to install separately, and you also have to install NumPy MKL. So anybody having Windows machine?
Some of these libraries don't work with
Yeah,